Welcome back to my channel, Dr. Zulilmi, where here we'll discuss about statics. My last video, we have discussed about moment in 2 dimensions. So today we will continue on the moment in 3 dimensions. Okay, so moment in 3D, we have moment equal to R cross F. Okay, moment equal to R cross F, or R cross F, where we have the F is equal to force vector and R is position. Okay, moment is the force vector and the R is the position vector, meaning that force vector F is force in 3 dimensions, meaning Fxi plus Fyj plus Fzk, and the R is position vector. Okay, it starts from the position where we want to take the moment. Okay, so we have 2 points. Okay, before we go further, here we should notice that the one that I write here is moment about a point. Moment about a point. Okay, so moment about a point is R cross F. F is the force itself and the R is the position. It close to what we have done in 2 dimensions. Moment equal to F D. F is the force, D is the distance. Okay, 90 degree to the line of action of force. The shortest distance is the D. Okay, so now it is close to that one, M R cross F. But the thing is, you cannot do moment equal to F cross R in this case. Okay, because it's 3 dimension, it will not give you the same answer. Okay, so moment, again, moment about a point is equal to R cross F. The F is the force vector, Ijk, and R also position vector in terms of Rxi plus Ryj plus Rzk. This is moment about a point. Later on, we go to the moment about an axis. Okay, we have 2. Okay, so the resultant of the moment about a point is still vector. So at the end we have moment about any point. Let's say we have A equal to MAxI plus MAYJ plus MAZK. Okay, we will still have this one. Okay, in terms of 3 dimension for the moment. Okay, so here let me just write here F equal to Fxi plus Fyj plus Fzk. R equal to Rxi plus Ryj plus Rzk. So all in 3 dimension. Okay, so what we can do is moment equal to R cross F. So what we do is we have here, let's say I put it here, from there, so moment equal to R cross F, which is I put inside the R, Rxi plus Ryj plus Rzk. Okay, cross Fxi plus Fyj plus Fzk. Okay, so that is for, we will do this one. The cross product will be the moment. And okay, the force, we have discussed a lot about the forces, where we have force and then we transfer the force, convert into 3 dimensions in terms of I, J, K. But we still not discuss about the position vector. Okay, so the position vector R position vector. Okay, so the R, the position vector. R, the okay, so the R is the position vector. So the starting point of this position vector equal to your point where we take the moment. Okay, meaning that if you want to take the moment about point A, so you have to start the R equal to R A something. So you must always start from the position where you take the moment. Okay, and then end point. Any point on the line of action of force. Okay, so any point on the line of action of force, okay, can be your end point for this one. So, for example, if I have, where is it? This one. Put it away. So let me have Z, X, and Y, and then I have a, where is it over here? There is a force there and the point A. Let's say I have a point here, and then we have one force F1. Okay, so let's say we have this one. This is point A. Okay, so the R, in this case, the R, if you want to take the moment about point A, it is R cross F, so the R must start from R A and then something cross this F1. Okay, it must always start from the point here where you take the moment. The end point is any point on the line of action of force. So this is our line of action of force. Okay, this one. So the end point can be any point along this line. Can be any of this. Okay, you will see when you do the exercise, there is some point which is easier for another point where you can take the direction. How many distance from X, Y, and Z. So that you have to choose wisely. We look at when we go to action. So the R can be from A to, let's say we have B, C, D, E, F, G. So any of these can be your R. This is R, 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 R. Okay, any of these can be your R. Whatever point you take, as long as it is on the line of action of force, you will have the same answer. So the R can be RAB, RAC, RAD, RAF, and so on. Must start from A, because we want to take the moment about point A, and to the point on the line of action of force, so that you choose the easiest point where you can take the distance in X, Y, and Z direction. Okay, so that is for R. Okay, so it's clear. The force, we have talked a lot, so you know how to convert the force using first angle, second angle, coordinate, and so on. So you convert that into IJK, and then we have the R, which is start from point where you take the moment to any point on the line of action of force. You choose the easiest one. Okay, from the question you choose the easiest one where you can take the distance in X, Y, and Z direction. Okay, so that will be your R. Okay, so you have to take account the positive negative. If it is go negative X, so you put negative something, and then if you go positive Y, you put positive. Okay, it depends on the direction because it is a vector. Okay, so it is a position vector. So we said vector, so we must have the direction. Positive, negatives is counted. Okay, so and then we do R something. This one you can choose one of it. Cross F. Never F cross R. It is R cross F. Now you know the R. Now you know the F. Okay, so we we continue how to calculate this one. Okay, so R position vector, this is done. So let's say we want to take the moment about point A equal to R, choose one of it, okay, maybe RAD cross F1. So RAD equal to RXI plus RYJ plus RZK, and then we cross FXI plus FYJ plus FZK. Okay, plus FZK. Okay, so later on, what you will do is, you will do it one by one. This one, cross that, cross the other one, and cross the other one. Plus this one, cross here, and cross here. And you will do the same for the last one, which is this one. We'll cross this one, go to this, and lastly go to this one. Okay, so you will have a long list of equation. So I'm just putting some of it. Okay, from here, what we do is Rx Fx. Okay, I cross I. So Rx Fx I cross I plus Rx Fy I cross J plus Rx Fz I cross K, and so on. So Ry Fx, this one, Ry Fx J cross I plus Ry Fy J cross J plus Ry Fz J cross K plus Rz Fx K cross I plus Rz Fy K cross J plus the last one Rz Fz K cross K. Okay, so you have this one. This one Rx, Fx, Ry, Fy, and so on. It is, you will be a number later on. Okay, because we have the value of force, the value of position vector. So it will be numbered, and then it will leave you by I cross J, I cross K, Ji, and so on. Okay, this one we cannot leave it as this. Okay, so you have to go to so you have to go to this one. Okay, we use in your books here, I think page 69. We have we use the right hand rule. Okay, we use right hand rule, this one. So you have this R, J, and K thing, and then you move that direction. Okay, this one you have right hand rule. So we move this. Okay, so meaning that I cross J equal to K, K cross I equal to J, and if we move oppositely, I cross K will be negative J, K cross J negative I, and so on. Okay, so we use this one, right hand rule, and the other one is, you will see that from here. So what we have here is I, Ij, Ik, and so on. So I cross I cross J, I cross K equal J cross I, J cross J, J cross K equal K cross I, K cross J, K cross K Okay, and here it said that in this one we have vector cross product. For vector cross product, we have thing that P cross Q, okay, cross product is actually equal to PQ sin theta. Okay, PQ sin theta. Okay, so sin theta is the angle between these two forces. Okay, in this case we have from the R and the F, so the angle between these two, and then we know that the angle between I to J, J to K is always 90 degree. So we have sin 90 equal to 1, sin 0 equal to 0. Okay. So that's why from here any 0 angle will be 0, meaning that we have here I to I, okay, meaning that on the X this one will be 0, J to J will be 0, K to K will also be 0, okay, from here. Okay, but the other one we have to follow this. So I cross J, this one K, I cross K, negative J, JI, negative K, JK, JK, so I, K, I, J, K, J, negative I. Okay, so this part you will put it all here. This one is 0, J cross J, this one is 0, K cross K equals 3. So the whole thing here will be 0, 0, and 0, and then this one you transfer. For example, this one IJ will be K, and so on. Okay, and then later on you will simplify this one. Okay, I have simplified that one, and then you will get the value as not the value. You simplify, and then you will see that you not have the I, J, I cross and something. You only have in terms of I, J, and K. Okay, simplify that one. Put it together. In the I direction, you plus everything in I. J direction plus everything. So what you have is later on. This one I have already simplified. R FZ minus RZFY in I plus RZFX minus RXFZ in J plus FY K. Okay, so you have this one. You simplify. There is one more step in between here. You eliminate the one is 0, and then you plus everything in I, J, and K, and then you simplify. You can have this as your answer. Okay. Later on, this answer it is a number because the force will be number some value. The R also there will be a value, so it will leave you something like 500 Newton J, okay, 500 Newton A plus 200 Newton J and something, okay, Newton K. Okay, so again, moment about point R cross F. R must start from position where you take the moment. If it is point A, must start from A. D, the end point, any point on the line of action of force will be okay. Any point you take, you will having the same answer. Okay, and the cross F, you never do the F cross R. They will not give you the same value. So you do the R cross F. Okay, so you cross one by one. You get this one, and then transfer the I cross I, J, and so on using this right hand rules. This one, so from I moving to J, moving to K. So it is a sine. The cross product is a sine theta. So the one that 0, sine 0 is equal to 0, sine 90 equal to 1. So this one I, J, K will be 0. The other you follow this one, and then you use this to transfer here, and then you get the answer. This one way. Another way is you can use the what we call it as determinant. Okay, so you can use also the determinant. Okay, you have this one. Okay, so let's say you use the determinant R cross F, and this is R, this is F. And erase this part. Okay, so you can use also the determinant where you have R and F. So the R, in R we have I, J, K, I, J. So we put R here and we put F. So R must have RXI, RYJ, RZK, RXI, RYJ. F, FXI, FYJ, FZK, FXI, FYJ. Okay, so you do it one by one. Okay, 1, 2, and 3. So we're going to have 3 from here, and then 1, 2, and 3. Okay, so what we will do is, you will take this direction, 1, 2, and 3. So the one that goes downward, this one plus, will minus the one that goes this one. Okay, so that one will be, I don't have any other color, so we start by here, thumb, thumb, thumb. This one. Okay. So another way is, if I simplify this one, you can have something like RYFZ. So RYFZ. I. This one. Plus RZFXJ plus RXFY K minus RYFX K minus RZFYJ. It is I here minus RXFZ J. Okay, so you simplify, put I together. So this one will be I. So I'm taking RYFZ minus RZFY. Okay, I plus J, RZFX minus RXFZJ. You see that here it is same. Okay, RZFX, RXFZ. So plus the K1, RXFY minus YFX. Okay, so you see that this one and this part, you have the same answer. So you can either use one by one, cross one by one, and then use the right hand rule to transfer from I, J, K, I, and so on, and then you can have this answer simplified. Or you use the determinant, the one that goes downward, plus, and the other one goes upward here will be negative. So you put it everything and you simplify, you still have the same answer. There's two ways. Okay, so you can choose which one easier for you to be done. Okay, so that is for moment about a point in 3 dimensions. We will look at later on, of course, the example for a clearer image of how to solve this one, how to use this all equation to solve the problem involving moment about a point in 3 dimensions. Okay, so we continue later on.